Could I just start?
All right. Um,
Yeah.
Welcome everyone. This is another Friday, another session of Amplifying F Sharp. We will do a short introduction of what we do here, and then we will have the today's presenters. Let me briefly introduce you to Amplifying F Sharp. We are an initiative from community members to help F Sharp's ecosystem to spread the good word, as Jonas said a couple of minutes ago. Last week, we had a very interesting session about the news in F Sharp 9. If you're interested in it but missed it, don't despair. All our sessions are recorded on YouTube. The HD recording playlist has all the HD recordings, so you're good with the um, code reading there. So yeah, I think um, we have you covered. If you're interested in doing such a session after getting an idea from the recordings, just go to join us today and you can get in contact with us. We can help you fix a concrete bug or a concrete feature, start with a concrete feature you have in mind. Um, Also, we are running a little open collective to collect a little bit of money to drive somewhat larger contributions to various projects in the ecosystem. And yeah, that's pretty much about it. Let's go to today's session. It is somewhat of a follow-up of Jonas' session in the Funkpok Sweden meetup, which was a great success. And Scott was interested in deepening the discussion, and Edgar made his magic work of bringing people together. And so here we are today. And with that, yeah, I will give it up to Jonas, and he can educate us about a very interesting alternative way how to model single process microservices.
Hey, thank you, David. I'm really happy to be here and spread the word. And I'm also really happy to be here with Scott, who will share his insights into microservices and domain-driven design, because I think these two are very tightly coupled in many ways. So let me just start my slideshow and share my screen. Click on that. And all right, you can see my slides.
Yes, it's all good.
Yes, very good. So just a few short words about myself. So I'm not a computer scientist. I'm actually a chemist by training, but I've been a computer geek since I was as a kid, and I've been programming for, I realized, nearly 40 years. And I've been a professional programmer for about 25 years or so, and programming functionally for 13. And 10 of those have been in F sharp. So I came originally from Haskell and in that world. That was the first functional language I learned. I wouldn't recommend it to anybody. Not because Haskell isn't a great language, it's wonderful, but it's kind of hard. It's like learning traditional object-oriented programming from C++. It's the wrong end to start in a way. I've also been teaching at the university, master's level course in sort of aspects of functional programming, and we've been using F sharp as the language. And those videos are on YouTube. I recorded everything during the pandemic when we couldn't meet in person. Just for the benefit of anybody who isn't yet a full-fledged functional programmer, I just want to say, because I think this is important, when you start out, there are a ton of new ideas, new nomenclature. There's a lot of jargon going on when you talk to functional programmers, and it can be quite a sort of overload. I remember being quite sort of confused in the beginning of what is what and how things work, and how can you actually write any software in this manner. Relax. Functional programming, suddenly it clicks, it becomes completely normal programming, just less painful. And about F#, I was a bit skeptical coming to F# 10 years ago, coming from Haskell, and I was doing a bit of Idris, and I was, all the fancy stuff that they had, and I looked at F# and it sort of looked like quite a bit more primitive and not so fancy, and not that any monads or hylomorphisms to be seen. But I quickly realized that F# is really, really a fantastic engineering language. If you want to get stuff done quickly and clearly, and just get features out, F# is probably one of the best engineering languages out there, in my opinion. So I'm currently the CTO and co-founder of a company called Oceanbox. We've been running for 2.5 years, and we do digital twins of the ocean. So we set up these big mathematical models of the ocean and simulate like the weather forecast, but for the undersea. And this we do in a way that is completely self-service to our customers. They can go in and get all the data they need, and they can run their own simulations and trajectories for things. And all of this is more or less completely implemented in F#, both the back end and the front end. And currently we have more than 600 terabytes of data, oceanographic data online that is being accessed every day by our customers. And the code base is currently in excess of 100,000 lines of code, both in pre-production and in server side and client side. So I just want to show, here's another simulation. All these things I show are just screenshots essentially from our tool. So here's the difference between June 2023 and 2024, the sea temperatures in the north of Norway, where I happen to live. I actually live on this little island here, Tromsø. And today is the first day in 2 months when the sun will not rise at all. So hello, darkness. And as you can see, I mean, it's quite clear that this was an exceptional year because the sea was much, much warmer in 2024 than it was in 2023. Another thing that we do, and this is really important to our customers, which are currently mainly in aquaculture, is the ability to run their own trajectories and see how things move in the sea. So here's a simulation showing parasites, typically sea lice, or it could be a virus with a certain biological properties on it, and see how those get transported over time from a locality here, and the concentrations and average concentrations of those things. And then you can pull out these time series analysis of how certain sites will get affected by a plume of, or this longer discharge of parasites from a locality, which is very important if you have your livelihood in the sea. So that's the essence of what we are doing. Right. So of course, when we started Oceanbox, we started completely from scratch. We had nothing. And we started designing how should the system look like, how should we build it. And of course, being serious cloud architects and programmers, we of course went for microservices, as you do, without really thinking too much about it. So we did our domain modeling exercises. We found the boundaries, and we built these services, and it sort of, everything was kind of looking good. After a while, we started realizing that instead of having one problem, we had created 5 new problems, or even more, because things got really, really hard to manage. I was spending almost more time hoarding services and manifests and updating YAML files and just making sure that things are running, and network policies and what have you not, instead of writing features for our customers. And that was not a lot of fun, to be honest. And we also realized we had lots of code duplication. Debugging is kind of hard, but that's always the case, almost. And then it was the sort of the performance and monitoring of things. So the bottom line, Heinz ketchup cannot help broccoli. Domain-driven design, great, really good, solid to think about. Microservice architecture, I think, is brilliant, and Scott will talk more about that. But microservices, as in separate services, is really not so much fun. And at this stage, I remembered an old thread on Twitter that Scott had posted about the single process microservice architecture. And I reread it and realized that what I needed to do. And at this point, I think I'll hand over to Scott, and he can talk about his ideas, and then I'll continue from there with a little demo.
Excellent. Okay, thank you. Thank you, Jonas. So let me just share my screen here. Right. So yeah, so just to pick up from where he left off, this idea of people if I think that microservices is the only way to get good domain-driven design and good microservice architecture. So I had a funny series of tweets, which I'll just show you the tweets. So I call this thing SPMSA, a new alternative to microservices that addresses many of the problems that people have with microservices. Yeah. So you design your microservices in the usual way. So you make them small and you have well-defined interfaces. And then the first trick is you put them all in the same repository, right? So you have a single commit for all your services in one go. And then what's nice about that in terms of refactoring stuff, because they're all in the same repository and we have one giant set of source code, it's really easy to do things like refactoring. And all the services are guaranteed to work together, which is sometimes a problem when you have disparate services in different repositories. So that's good. And then you deploy all the services at once, because again, you have in microservices, you often have a situation where some of the services are slightly out of sync in terms of their APIs and stuff. So you just redeploy all the services. Every time you make a change, you redeploy all the services at once. And that shouldn't be a problem, because if you have a continuous delivery pipeline, it shouldn't be a problem, right? And then the next thing is you have them share memory, because one of the big problems with microservices is the communication on a network is kind of slow, and also you spend a lot of time serializing JSON. I remember someone actually said they actually were looking at 50% of their time of their services actually serializing and deserializing JSON. That's one of the reasons why people switch to using protobuf or something. But anyway, you spend a lot of time on network stuff which is not directly relevant to your service. So if you have all your services share memory, they can communicate much faster. So that's good. So now you have, a single repository and shared memory, all these services. You don't have any latency. You don't have any availability. All the services are always available all the time. So there's this thing called the fallacies of distributed computing, which if you haven't seen it, I highly recommend reading it. Here's the Wikipedia page. And it's about, the network is reliable. Network is not reliable. There's always latency. There's always bandwidth problems. There's always security issues, and so on and so forth. So distributed systems always have problems. So here you go. So this is my whole idea, right? You have a modular system, small single responsibility services, but you don't have any issues associated with traditional microservice. Now I call it traditional microservices because they've only been around a few years, but everyone seems to think this is the only way you can do microservices. So there you go. And then of course, if you have an SPMSA platform, that you can actually share different languages and using the same shared memory. So Java and Scala, or C# and F# and .NET. So that's nice. You don't always have to pick the same, because people say with traditional microservices, each team can be using a different programming language. And I think that's a bit of an overrated thing. But like I say, you could have one team using Java, another team using Scala, or one team using C#, another team using F#. That's fine. That works perfectly well. And then in terms of scaling, now that is the problem. Being in a single process, you can't have individual services scale independently, which you can with a true microservices. But normally most people do not have a problem. You know, if you're Google, yes, you might have a problem. But otherwise, there's something called threads or forking even, which allows you to actually have multiple things running at the same time from one thing. So that's what I would recommend. If you really need to scale out your individual services, you can run 2 of them at the same time in the same process. Amazing. Okay. So that's what I call single process microservices architecture. And I think this is going to be very trendy. When I wrote this, this is sort of 5 years ago, I wrote this. And I said, this is going to be the next trendy thing. And I was right, because it is becoming the next. I see a lot of people getting fed up of microservices for exactly these reasons. So I think this will be the new hot thing. That was what I said 5 years ago. Anyway, now it's interesting. Some of the people had funny replies. They said it sounds like a monolith. And I said, well, actually, it's got the word microservices in it. So it's better, right? Because monoliths are bad and microservices are good. And this is when the microservice hype was like full blast, right? So if it's got microservice in it, it must be automatically better than a monolith. So this is not a monolith, it's just microservices. And then someone said, are you making fun of monoliths or not? And the answer is yes. So that's that one. And then I always like to put this thing from Spinal Tap, for people who haven't seen it. It's a fine line between stupid and clever. So when I posted this, it was kind of silly, but it's also kind of serious at the same time. And I'm glad that Jonas picked up on it and actually decided to run with it, because I think it is, yeah, it's worth trying out. And another thing I just want to say, I also put in my replies is, people say, why do they make up a new word for something? And the reason is that sometimes you can take an existing concept like microservices or monoliths, which is a bad word, and if you just give it a new definition, you have exactly the same concepts, but you change the definition, or you change the word you're using, people see it with a whole new light. I mean, a good example is SOA, service-oriented architecture, was considered very bad because it's big enterprisey. But then you replace it with microservices, and that's good. It's the same, it's exactly the same thing, you know. And enterprise service bus are bad, but Kafka is good, you know, all this kind of stuff. So just think about the actual, what you're actually doing, not the jargon associated with it. Because the people, especially big companies, they pick up on the jargon. Like Agile is a good example. They pick up on the jargon for Agile, and they don't understand what Agile is. So rather than talk about Agile, just say fast responsiveness, or quick turnaround, or rapid deployment, or something, rather than using the word, because the word gets contaminated, So that's my take on that. Okay, so quick thing on domain-driven design. And what does that have to do with microservices? Well, so in domain-driven design, we have these things called bounded contexts, which are independent subsystems which have their own vocabulary, their own logic, their own way of thinking about things. And they're independent because different teams or different subsystems actually think about the world in a different way. And if you think about in a big company, you have different teams, and each team uses their own vocabulary and they have their own jokes and their own way of thinking about things. And in software, it's the same thing. Each subsystem will have its own way of thinking about the world. And in domain-driven design, we call these bounded contexts. They have boundaries and they have their own context that only makes sense within the vocabulary, and the way it works only makes sense within that context. So that's what it's probably the most important, one of the most important concepts from domain-driven design. And if you think of them as a self-contained autonomous subsystem, that is very close to a microservice or a service, right? So what is a bounded context in domain-driven design maps really, really nicely to a service or a microservice in terms of architecture. So this autonomous thing is really important to domain-driven design, because first of all, they need to evolve independently. So each one of these subsystems should be able to evolve without asking permission from another system. The whole point is these things are decoupled, right? They're autonomous, they're independent. So if you have to ask somebody else, can I change this? You're not independent, you're now coupled to them, right? And along with that goes having your own private data, because if I want to change the database schema, if I'm using a SQL database, if I want to be able to change the schema, I should be able to do that without asking permission. So if you want to evolve separately, you want to evolve the database separately too. So you need to have private data. And then finally, one way things that get coupled is coupled in time. So if I have a synchronous API call, an RPC call to another service, and that service stops working, then my service also stops working. And so my service is now coupled to the other service. And that's not necessarily a good thing. So one of the ideas here is if the other service stops working for some reason, you can keep going. And the way you do that is by having asynchronous communication using, asynchronous buffered communication, which is a queue. So if you have queues between these things, then they can definitely stay independent and they can evolve separately. So that looks just like how you do services as well. So these bounded contexts in domain of design map really well to services in architecture. So here you go. We have two different kind of bounded contexts or services, and somebody wants to tell somebody else about something. So they have some sort of queue, some sort of asynchronous buffered way. It could be an event thing like Kafka, or it could just literally be a queue like RabbitMQ or something like that. It depends. But the idea is they're decoupled in time and they're decoupled in space. But there's no reason why these things have to be physically deployed separately, right? So if you have this, particularly when you say you have these different servers connected with queues, the obvious answer is let's deploy them as separate independent services or microservices, right? So that's each of these things is now deployed separately with queues. But in my way of doing, which is a functional domain, you can actually also deploy them independently as single lambdas or in a serverless model. But you can also deploy them as one giant monolith where they talk to each other. And that's what the whole point of the single process microservice architecture is. There, it's a single process, but you're using microservice architecture within the process. So you get all the benefits of the microservice architecture, right? So you get the autonomy, you get the fact that they stay separate, they communicate through an explicit API, they can evolve independently without talking to each other. That's all good. But because it's one single process, it's super easy to debug because you can just switch between processes easily. It's super easy to refactor because everything's in one repository, and it's super easy to deploy. You don't have to, use a very complicated system for deployment. So that's why I think SP. I mean, I was originally doing it as a sort of a joke, but I actually think it's quite a good system to use. So back to Jonas now.
Thank you. Get my screen back. Here we go. Yes, so that was good. So what does this have to do with actors then? Well, actors actually, in my opinion, is a really good fit for doing the SPM-SA. Because back in the day, I used to do a little bit of Smalltalk programming because I like programming languages. And then I realized that Scott also has a knack for Smalltalk. And in Smalltalk, everything is actors basically. So you communicate by sending messages. This is the original form of the object orientation. But instead of actually calling methods directly like you do in common OOP, you actually send a message. And this is very, very important that you talk via message passing, because this means that in an actor, there is a queue, which again, if you think about what Scott just said, that you have a queue between your services, there's a queue and you send a message to the queue and then get processed and then the next message and the next message, which means that you will never ever have two things updating the same state in the same time, because everything is sequential inside the actor. And in Smalltalk, it's kind of extreme, because there even if you want to call a method on the same object as yourself, you have to do it by message passing, typically. So that's sort of the actor thing. So this is the sort of the thing with message passing with actors. They actually enforce a certain order on things. The other thing with actors is that they maintain an identity and they can have state. So that means that you can have a lot of actors. So you can have an actor, for example, with a granularity of a user. So you can say, well, every user that logs in will have an actor. So this is typically what they're doing in the Norwegian broadcasting system, where when every time you log on to your log on to listen to your podcast or watch stream some television, there's actually a bunch of F# actors, Orleans actors firing up, and they remember you, your identity, which programs you watched, and all of these things. So that sort of shows you have the granularity of a user on an actor. But you can have, if you need to, since they are sequential, you can actually put them, you can have a different granularity, which is more suitable for your problem. Actors are concurrent, meaning that you can, if you need concurrency, you can just have a ton of different actors doing things. They all have unique identities and they will do their thing concurrently. Internally, each actor can only be sequential, and this is important. And for those who are a little bit more theoretically inclined, it's also a model of computation, so which means essentially that this is not just some hack. There's a lot of theory to it, and how that they are sort of also mathematically sane. So in the example I'm going to show soon, I'm actually implementing actors using a library called Dapr. And for those who don't know Dapr, I just want to mention it because I think it's really, really a great invention for anything microservices, distributed or not. So one of the things with Dapr is that it's language agnostic. So they decided to do everything with HTTP or gRPC. Dapr implements same type of actors, virtual actors, as in Orleans. So there are all these different actor implementations like Akka and Orleans and so on. Dapr uses the Orleans type of actors, which is kind of lightweight and kind of easy to understand how it works. It's very easy to grasp. It also contains libraries for service invocation, service discovery, secrets management, all kinds of things, and also something now which is in beta, which is workflows for really long-running processes. And I actually planned to put in a little bit about workflows, but I decided against it because it's kind of off topic. So if we start looking at monolithic microservices and using Dapr, so well, how does this work? And I think I think these actors are kind of a sweet spot for doing these monolithic microservices. So here's I think Death Star is a good example of this SBMSA. It's terrifying, but also very powerful. So what we get with the actors is that we get strict boundaries. The actor you can only communicate with the actor from the outside via message passing, via essentially a virtual queue. The actors they fire up, they live for a little, you can define how long, so you can say it should live for a second or a minute or 10 minutes or 5 hours, you can configure that. And as long as that actor is active and alive and hasn't gotten replaced somewhere else, it will be running. And this means that every time you call an API, which then will call an actor, it will go back to the same actor, which means that it can keep things like files open for you. So you get the kind of a session affinity, which might be something that you need. For us, that was one of the important things why we chose to do actors in the first place, because we have these big archives with these huge files, and they're kind of costly to open and close all the time for every request. So by using actors, we could actually have the actor keep the files open for a minute or two, because we know that it's very likely that the user will access the same file multiple times before switching to another file. So the other thing is observability. So when you use Dapr actors, it will automatically, every time you call an actor, that call is automatically instrumented. So you actually get fairly fine-grained instrumentation on your in your code without doing actually anything. all you have to do is just set up OpenTelemetry Collector or Zipkin or something, and it will just collect the traces for you. They're very high performance, so most of the communication goes over gRPC, and actors will also allow you to scale horizontally. And this is kind of nice because I can just fire up in Orleans parlance, it's called a silo. So each container would be a silo, and then your actor is a grain, and it can jump. It will be in one silo at a time. But that means that if you have a lot of actors, you can just scale your service horizontally, and your actor will be running somewhere. And if the runtime decides that this service is overloaded, it will just relocate your grain to another silo with better resources, which is quite nice. So the way we are doing things in currently is that we used to have 5-6 separate services, and in those services we actually had, each of them had their own ASP sort of set up, the usual boilerplate for setting up the pipelines to routing and ASP.NET Core, web hosting, all of these things. And originally we had built all of this stuff with actors. So that when I wanted to make this SPMSA out of this system, all I did was actually remove the sort of server code and just keep the essence, the service code. And I put all the services in separate folders inside the project. And that was basically it. So in principle, it was a very, very quick process to turn the distributed system into a monolith. And then I could just scrap some 1,000 lines of YAML manuscripts for deploying. And so it's brilliant. And the other good thing is that it's really easy to split back out if you need to. So if you suddenly realize that one part of your system is you need to scale separately, it has completely different scaling properties than the rest of the system, you can actually very easily just pull out that subfolder, put it in a separate project, put an ASP.NET server code around it, and send it off. And the cool thing with using these actors and the Apper service service discovery is that you can fire this thing up separately in the running system, and Dapper will notice that it's there. It will update its placement tables, and suddenly you will start getting, you just essentially added a new silo, like if you would have taken your original app and scaled it horizontally. But now it's actually running in a completely different service. And then you can remove it from the old one and you can replace it, and you have completely transparently split your thing out into actual microservices again. And if you don't want the stickiness, that you actually get the session affinity and sort of stickiness of the service, that you actually want it to be totally stateless, Dapper offers something called service invocation, which gives you all the benefits with service discovery, but you don't have the statefulness. I actually put in a small example of that in the code just for reference.
So can I ask can I ask some quick questions before you move on?
Please.
So the first question is, why did you pick Dapper instead of Orleans or Akka.NET, or there's a whole bunch of other agent frameworks that you could have picked?
Yeah, I was surveying a whole. I hadn't heard about Dapper, and it wasn't on my radar. And I was looking at things like NService Bus, and I was looking at traffic or whatever it's called. I mean, there was a bunch of these things in order to achieve this. And then I looked at Akka, and that was kind of, it somehow rubbed me a little bit the wrong way. I thought it was kind of complicated. I was at the F# meetup at NRK, which is the broadcasting company, and they have a lot of F# people, and they said, hey, no, you should use Orleans. It's much, much better. So I looked at Orleans, and I did some things with Orleans. What I didn't like about Orleans, at least back then, was that it was purely .NET. So I was stuck on the .NET platform, and it was just actors. And then I found Dapper, and it had the same actor code as Orleans, but it also had service invocation. It also had these workflows. It also had like secrets management. You have all these things that everything I needed. So it was like this Swiss Army knife of things, and it was language agnostic. So it was very easy. I tested it out, good documentation. In a day, I was up and running. But that's why I picked Dapper.
Right. Okay, so let's got a couple more questions if you don't mind. So the next one is, if you're using actors, how do you kind of ensure, you know, like in F# we like to have our strictly typed interfaces, right? We don't just randomly. How can you ensure that kind of stuff in an actor model?
Actually, Dapper already supports it by and large, and it's not completely perfect because the standard Dapper, all the interfaces, they're fully typed. So you just, I'll show you in the example how it actually looks like. There is a little caveat, and that's that if you try to pass F# unions between things, you actually need to take care of deserializing and serializing the JSON or the payloads yourself.
So would it be like designing DTOs, designing types which are specifically designed to be serialized? Basically, if you have simple record types with simple strings and ints and stuff, that serializes them automatically.
Just absolutely automatically. You don't have to do a thing.
So you still have a little bit of a boundary between turning it into a DTO or some sort of objects designed to be serialized easily.
Yeah, but typically I find that most of the time it just do the natural interface to a method, and like any OOP type thing, and you just use it.
Right.
So
okay.
So there's very little overhead actually.
Right. And then in terms of, you said one of the problems was debugging, or one of the things I said is debugging in a distributed system. Is it easy, even though they're actors? I mean, how would you go about debugging something when you have a lot of different individual agents who are talking to each other?
So, well, I guess we don't debug much in F#, right?
You can debug the individual. I mean, for example, can you start an individual actor up in a debugger and trace through the steps in it?
To be honest, I haven't actually tried.
So you rely on the telemetry. You probably rely on the telemetry and stuff.
I do a lot of I use the telemetry for yeah.
And also, so one final thing: can you scale up the individual actors? Let's say you have one actor that does need to be scaled up. Can you scale up within Dapper so you start running multiple services even inside the same, using threads or something?
Yes. So, well, you should be a little bit careful what you do inside an actor. But of course, what you can change is
right.
So you can have like 10, you can have like, if you, for example, you use the user ID as an ID for an actor, you can of course always put on like a /1 2 3 4 5, and you can make 10 of them and just let them run. And so that's one way of doing it.
And these are all running in the same monolith, right? You might have multiple actors.
Yeah, but you can if you just go and say that in Kubernetes, for example, if you're just going to say that it should run 6 replicas of your service, it will start up 6 pods. They will all automatically connect with each other, very similar to Erlang. Figure out, okay, here's the thing, and then the Dapper runtime will just start putting your actors in the multiple processes. Then you will be actually running over the network, though.
Right.
So then it's not like a monolith, but code-wise, it's a monolith.
Right. It feels like you're writing a monolith when you actually write the code, is what you're saying.
Yeah.
Yeah. Okay.
And everything is monolithic about how you deploy it, how you manage it, everything, except that it actually you just scale it.
And so okay. So another thing is if data storage. So does each actor has its own storage? How does that work?
It can have. So you can. There's a whole bunch of different state stores that you can have. So typically a Redis. So we use Redis as a state store. So if you need to store, so that the actor wakes up, it has some state that it needs to remember. So when it shuts down, it will store the state to the state store. And then when it wakes up, it will load the state again and be back exactly where it left off and then start working again.
Right.
And then you can use Redis or you can use S3 or Blobstore. There are like 15 different storage backends.
Right. Okay. All right. Well, I'll let you get on with the rest of the demo. Sorry. It was yeah.
Yeah, thank you. I'll just so here's just so the code for this is on my github.com, Uselius Monorail, and there's a little demo. So all the code I'm showing is on that is in that repo. And the structure of this thing is that I have a server project. It's my main. So this is kind of very close to the safe template for those who have used it. There's a top-level directory in there. There's a source. Under that, I'll have a client directory, a server, and then I have my services as separate projects, separate folders under server. So it's all the server side stuff is under server, but every service, every microservice is its own project inside that. So that's the structure of this thing. And the server is really trivial. It just sets up the ASP.NET web host. It sets up routing. There's a little bit of active registration. I'll show you how that works. Logging, telemetry, blah, blah, blah. And then I have written a client. As you will see, I'm not much of a web designer. But that's done with Fable and Google Lit. I've sort of gone down the Google Lit path in front-end stuff. I like it quite a lot. I think it's good. So let's see. Let's jump to the demo. I just need to. Can everybody see my screen?
Yes.
Good. So let me just reload that. It said fetched notes. So here I have just to explain what this is. Death Star here says shoot, and if I click on it, it's just doing some service invocation. So that is using. So if you look at when we look at the code, the shoot button will just do service invocation. Now there's a little bit thing going on because actually the service invocation will inject stuff into the backend so that which the user front end doesn't know. So if I reload, it will see that it added target Tatooine into the thing, but I have to reload. And then I have two separate grains. So these are two. So Darth is one actor and Obi-Wan is another actor. So these are two, or actor IDs, I should say, because they're not actors themselves. These are just the actor IDs. And if I now press on actor A, so what happens here is I'm using Fable remoting, which gives me, of course, type safe communication to the server. So the client will use Fable remoting. It will send a request to the server. It will pick it up. It will hand it over to an actor, which will do something and return a result. So what we see here is that here service A ran the method A in the grain Darth, which is sort of the actor ID here, in a silo called Monorail. So this is the name of my process, and there's a count. So you can see now if I press actor A number of times, the count goes up. So it actually, the actor itself remembers the state when it's in. If we wait for a while, I think I put it to 60 seconds, the actor will shut down. And next time I will press it, it will go back to 1 because I didn't save the state. So I'm in this example, I'm not using any state store, just to keep it really simple. Yeah. So that was actor A. I have another actor B that I can press. And actor B will actually do something else. It will run something on service B, but it will run the function A, and then which will then call service A, and then back. So now we have an actor calling an actor. And one of the things I wanted to show about the actors being sequential is that actor B here, if I press it, you see I pressed it and it should, there we go. It takes a little while. So I have actually put in a 1.5 second delay. And what happens now, if I press this actor like 3 to 4 times, we'll see that things are actually happening sequentially with this thing. So then I have this other actor, so I can press many of these, and they will run completely concurrently. So they will just run there in their own little world. So they don't interfere with each other at all. So let's wait a little while. While we do, I could actually go to, let's see here. I can start up, so now I can start up a version of this, which I have called Death Star. So this is exactly the same service. It's just running on a separate port. And what you can see down here in the lower window is that it says placement tables updated version 127. And that means that now the Dapr runtime has seen that I have actually started the same set of actors in another service. So we can go back, and now it said, executed endpoint Dapr actors deactivation. So now if I go back to my example and press A, it should say 1, and it does indeed say 1. So now the actor died, or it terminated, went to sleep, and now it wakes up, and since I didn't use the state store, it wakes up with a fresh state. So that's sort of the essence of this actor stuff. So I think maybe we should look at a little bit of code and see how this actually works. So here's so if you look at the side here, I'll just want to show you. Here's my server project. Just the client. I won't look at the client at all. Here's the server project, and it contains a service A and a service B. There's a settings file just to read app settings and service name, and it's completely trivial. There's a little thing I've implemented to integrate the Dapr stuff with Saturn, because I like Saturn, because I don't like I'm not particularly fond of the OOP stuff from ASP.NET. There's an API. I won't go into that. That's normal, just defining the APIs with using Fable remoting. And then there's the server. And here's the server FS. So let's start from down below. So I create the program, configure logging, and then here's the actual application. So set it up to listen. Here, my colleague Moritz has created this little nice thing, F# Open Telemetry, or Saturn Open Telemetry, I think it's called, where you can actually set up, really easily set up Open Telemetry, and it supports databases and OpenFGA and all kinds of things. There's a web app we'll look at in a second. And then there's use Dapr, and this is the one that was in the Saturn Dapr FS file. And all of the rest is just normal standard stuff to wire up a ASP.NET service. So let's look at the stuff up here. Configure actors. Takes actor runtime options, and then you just say actors register service A. Now, of course, my module is called service A, and the actor is called service A. Register actor service B. This is just so that the runtime can identify them, and then I set the timeout for the actors. the global timeout to 60 seconds. Here's the shooter thing for the intercepting the shoot stuff, and here's the web app using these endpoints. So we can go to the endpoint here. Okay, I need to increase the font size on this one a bit. So, okay. Let's just look at the invoke A. So here's how to use an actor once it's been sort of defined and everything. Here's just the function, handler function. It comes in with an actor ID, which is basically just your username or whatever you define it to be. You create the task. You say actor proxy create an actor of type iActor A, and you give it the actor ID. And here's a little quirk that you need to be aware of. So there's internally some reflection going on. So this is the name of the class that implements your actor, because you can implement the same actor in different classes. And that's actually what I've done here with service A and service actor A and B. So is that I actually have two different ways of defining the same actor interface. So here's service A, and then this proxy here will contain will just be a normal. It's just a normal type, and then I can say proxy run A, which is a method on the actor returning a task, and that's it. So this is how easy it is actually to use. Instead of just calling directly, have a object and calling run A on it, you just create this proxy object and you call the method on it. But that's it. That's all there is to it.
Quick question on that. So if I create two proxies with the same ID, does it reuse actors, or does it create a new actor each time?
No. If they have the same, if it's the same implementation, so both are implemented by the class called service A, and they have the same ID, they will always go to the exact same service, the exact same sort of running thread.
Right. So you don't have to worry about keeping track of accidentally running multiple ones, right? Good. Okay.
No. And actors are super cheap. Like you can have thousands and thousands and thousands of them, even on a small PC. I mean, these are not heavy things. These are really, really lightweight. Not quite as lightweight as Erlang, which I think consume like 300 bytes or something of memory, but maybe it's a few K.
Right, and then can we just have a look at the code for service A then? So that's just a regular class. Is that just a class? Is it?
That's just a class. So let's first look at the interfaces here. We can go to So is the interface for the actor. So it says type iActor A. It inherits iActor from Dapper. That's something we don't really have to worry about. And then I just define abstract run A. And then here's another little quirk that you need to be aware of. You need to put some labels on the arguments. You need to have names on them. Otherwise, it will not work with F#. Don't ask me why. But if I would do this, I would get weird errors. So that's just a little thing to know.
Could it be reflection?
I was going to say, it sounds like reflection. Yeah.
Yeah, they're doing magic.
Yeah.
So that's the thing.
It's using reflection to generate a proxy class.
Yeah.
Right. Okay.
So that's something, but in the background is going on.
Yeah.
So okay, so here I've just defined the interfaces, and now we can go and look at service A. Type service A, and here again, now I define a class called service A, and if we go back to here, we see that this name here, service A, must correspond with the name here because of these reflection things. We inherit from actor host, and these all get dependency injected automatically for you. So there's sometimes you need to have settings and stuff go into these things. So you can just add into the ASP.NET DI container. You can just add app settings or whatever you need, and you can just they get automatically pulled out here. Or if you don't want to use the configuration engine on Dapper, which is another possibility. So you see here, okay, I have a mutable count. I get a string representation of my actor ID, and then I implement the interface. And run A will just increment the count. It will output a message and return it, and that's it. And similarly for actor B, which I have here, it's pretty much the same thing, except that now I actor A implemented in service B, which also implements I actor A, but in this case, this I actor A will actually call a I actor A of service A, so that these are calling each other as a crisscross.
So so on line 19, where it calls the proxy, that is actually going through a queue. It looks like a direct.
Yeah.
That's why it's wrapped in a task, so it's actually asynchronous call to the right.
Yes. So that will then invoke. So now we would have two actors running, and it will invoke the method. It will get the result, and then it will sort of put it back into this one, and then it will return the combined thing. And then we have I actor B, which is the other interface, which has this run B method on it, and it sleeps for 1,234 milliseconds, and then returns. And this is it. I mean, it's not harder than this. You can have these actors return, as long as the return type is something which is, I think we could say C# would be able to serialize. You're fine. Union types, you have to be a little bit, you have to do it by hand, but it's also doable if you really need to. It just gets a little bit uglier. So that's basically it.
So this the code you're having here is running in, all this code is running in one process?
Actually, if we go back to, I'll show you here, there was this little thing. I started two processes because I wanted to show that you can actually scale out. And I started, so I was running monorail, but then I started one which is called Death Star, and we can actually see that there is a service here which has actually been executed on Death Star.
So when you call a service, it could be running in the same process, or it could be running in a different process.
Exactly, and you don't have to care.
Right.
And
so it will right. So it will just send it to whichever service is idle, or I mean, is there kind of any logic there, or is it just random?
So the Dapper runtime will keep track of these things.
Yeah.
And to be honest, I don't know how it decides where to run things, but it does a good job. So
right.
you don't have to think about it. You just it will end up anywhere. You can have like, so each sort of separate process is called a silo in Orleans speak. So you can have tens of them if you like, and then your actor will be running somewhere.
Right.
And I think actually, if you go for, there's a company called Diagrid, and they are sort of the main developers. So Dapper comes out of Microsoft, but Diagrid has become sort of the main developer of this, and they're doing a great job. And they have some advanced services for managing Dapper instances and getting all kinds of nice telemetry and stuff out of them. What I think you can do with it, the latest, they have something called Catalyst, is that you can actually have the Dapr runtime run in the cloud, and it can connect to a number of different Kubernetes clusters, so that you could actually have your actors run across separate clusters and continents, if you like, which is kind of cool.
Yeah.
And you get completely free. I mean, you have to pay Diagrid for it, but code-wise, it doesn't cost you a dime.
So the same code you've written here could be distributed across different regions.
Yeah,
that's
good.
nice.
So that's pretty cool. But you have to, one thing one has to be careful with actors is, of course, one thing is that internally each actor is single-threaded and sequential, and it's stateful. So terms and conditions apply as with everything. You don't use them if it doesn't fit your problem.
So you said there's something called service invocation, which I guess it just runs an actor and then kills it straight away.
It doesn't have anything to do with actors per se.
Okay.
It just uses the Dapr internal. So typically if you put stuff in Kubernetes, is that you will fire up a service and it will have a service name, and you will be you have to know what the Kubernetes service is. Dapr will just have this symbolic name for things, so you can actually put stuff anywhere, and Dapr will know where it is, and you can call it. So it sort of abstracts away the whole Kubernetes layer there. So that just makes things more transparent.
Right.
You don't have to do anything extra. One of the things I wanted to sort of conclude with, and I think I have this right, I haven't tried it out extensively yet, and it's in beta, which is Dapr workflows. And workflows are designed, they are built on actors, but they are designed for things that might run for hours or weeks or months even. And one of the things that I'm going to try to do with workflows is that we have this situation where a user might call an API, and that API might take 5-10 minutes to complete. And of course, if now the user sort of clicks or invokes the API, and they think, oh, nothing happened, something went wrong. They do it again and again and again. They fire off 10 of these things, each taking 5 minutes. And of course, in an actor, they will sequentially tie up that actor, and they will just sit there for 5 minutes, which is obviously not what we wanted. So workflows allows you to actually put an ID on sort of the workload, and then you can try to invoke it as many times as you like, but it just invokes it once. So then you can actually make sure that if it's just supposed to run this thing uniquely once, it will run and retry and whatever it takes to get your result in the end back to you. So, and that's also the thing I should mention about these Dapr things, is that if you just do things like communicate directly with HTTP, you don't get any retries, so you have to do that yourself. So if the service just happened to die and be moved over to another node in your cluster, or whatever happened, suddenly it doesn't answer. With Dapr, this is abstracted away. You don't have to think about it. It will retry a number of times, and you can configure it then. So in the end, you should get an answer, but you don't have to worry about it. And the less worries I have, the happier I am. So that's basically it. I have my final slide. I might just as well show it, which is this one, which is, again, don't be too Taliban. I have to remind myself. Oops, what happened here? So, and this is basically the terms and conditions apply. So this is one way of doing things. It's not the right way of doing it for every occasion. So, you need to do what's right for the right reason. It's good to have rules, but you also need to break them. The most important thing, I think, in development is to have good taste. Yeah, listen to Scott. He knows what he's talking about.
I just say don't listen to me. I would say on top of that, don't listen to any. You can get advice from people, but don't I hate, like some people, you have to follow this rigid way of doing something, otherwise you're not doing it right, and I don't like that. So yeah, definitely don't listen to me either. I mean, I can make suggestions, but I don't like the turning people into gurus. So yes, but other than that, that's all good. The rest, that's good.
See if I can stop my screen share here. I don't know how to do that. I'm pressing the stop
Yeah,
thing
there you
here.
go.
Oh, did it stop? No. Maybe, yeah, there we go.
I just revoked the permission for you.
Thank you.
Yeah, thanks. There was a lot of practical wisdom in this session. So thank you for sharing all your learnings. I really enjoyed the deep dive into the guts of this little demo code base. I don't see questions in the chat or on YouTube anymore, but if there are questions here in the session, feel free to raise your voice.
Yeah, feel free to reach out if you have any questions, and yeah.
Okay.
And if you have Dapper questions, the friendly people at Diagrid are they're super helpful, and there's also a really good Dapper Discord if you want to get into that.
Maybe one small one. So as you said, Dapper and unions are not so good together. So what do you mean? I mean, this reflection doesn't work, or like can I pass like a union into this function of actor?
Yes, you can, but you have to do the serialization and deserialization yourself, essentially. So I stumbled upon this on a few occasions. I got an answer from the Dapper folk about why this is so, and it had something to do with the .NET system text JSON serialization library, something not being, and they had to use it for some reason, and yeah.
So they can't use an F# friendly JSON. But
so the thing is that you can actually put in many instances you can inject your own JSON serialization. So I like to use this
right,
or whatever how you should pronounce
right.
it. Right. But it doesn't work with actors, so
Yeah.
it doesn't, and it's a little bit confusing. So I stumbled upon that thing. There's an issue on GitHub. It might get fixed. I don't know.
I would just put a plug in for my philosophy is actually to have, if you are having a very scalable system, is to have explicit data transfer objects defined. And one of the reasons is because they become the contracts between the different services or the different agents. And if you have them in terms of, if you break the contract, things can go bad, and by having a separate type just for the contract, it's very easy to check on when you're doing a diff on GitHub. Like if someone made a diff to those types, then I would worry that somehow the contract, I'd worry about the contract being broken. So by keeping them separate from your domain types, it's just a little bit of extra security in terms of, so yeah, I often do have specific types which are designed to be serialized efficiently, which are not the same. Because my domain objects get very complicated, but the data transfer objects tend to be very simple. They're just strings and ints,
Yeah, that's a good point. And another good point is that when you design your actors, since Dapper is completely language agnostic, it's much more convenient to consume them from Python or Rust or whatever you want.
Exactly.
Yeah.
I know you said you had in your production thing, you do have a couple of Rust services. Is that right?
We're not running. We have a little bit of Rust in the code base, but
okay, but not in the actual.
But not in running it. It's like pre-production stuff.
Right, but if you really did want to go the microservices approach, then you could actually have different teams writing in different languages, and they could communicate. Right.
Yes.
Yeah, we run Orleans, and we had a similar problem. We had to do a custom serialization for all our discriminated unions, and so that's an extra thing you have to plug in, but it does make it like a little bit more tricky because yeah, you have to account for all the various intricacies of how discriminated unions work. And if you work with a more simpler type, it does kind of allow you to be more open to later other programming languages if you have to later. Whereas this would be a
Yeah.
little more. I don't know how you'd end up parsing discriminated unions in like Python or something like that. At least in the, I haven't worked enough to know what that pathway would look like.
I can tell you how. You use Doug Bratley's F# to Python compiler, and you're good.
And the other thing is that each F# serializer, each one does it slightly differently. Sometimes they put tags in, sometimes they use a dictionary or whatever. So even the F# serializers are incompatible with each other. So that's why sticking with simple records with simple types is, yeah. It's also good for storage too. If you, I mean, the same reason that if you're storing things as JSON, it's nice to have again some sort of contract between the storage system and your code.
Yeah.
There's one question in the chat from Giulio. Is there any important constraint to be considered when installing Dapper on a Kubernetes cluster?
Not really. I mean, it's easy to install just using there's a Dapper CLI. You just say Dapper init -k, and with the right permissions, it will create the namespace and plug it in. The one thing to be aware of is there is one Dapper instance service thing for the whole cluster, so it's operating like it's global for the cluster. Dapper actors used to be, unfortunately, not namespaced, and this was a big issue for us because I wanted to run the same actor with the same name with the same code, but in staging and production and review versions and things. And suddenly I just fired up everything, and of course the Dapper runtime, which is global, looked at this and said, hey, there's a new silo, and then it would send actors to my experimental version, and that would break things badly, and also very hard to test because you would think you were testing your staging version, but it was actually running the production actor, and yeah, mess. So we ended up using virtual clusters to do that. Now they have namespaced actors. So now the actors are running in the namespace and only in that namespace. Now the problem there is currently this is going to be fixed, but currently you can't talk to actors in separate namespace. Then you have to actually put a little service invocation thing to proxy that request into a different namespace. But minor details, really.
All right.
So, but it's simple to run, and then of course you can go to Diagrid Catalyst, and then they will take care of this, and then you're free to do pretty much anything. I think it's super flexible. I haven't tested it myself, but I looked at it, and I will go that route, I think.
All right.
Yeah.
Any more questions, or should we wrap it up for today?
I still have one small. I mean, there are a lot of different actors frameworks. So, and I just asking. So maybe there are some fork of Akanet, so called Aklink. It's like F# native, so to say, way to. Have you considered or some? I mean, asking because maybe you have some experience with this or something.
No, I haven't. I looked at it very briefly. I decided to go with Dapper because of all of the sort of extra stuff I get with it.
Okay.
So we are a very small development team, so we need to keep mental load as low as possible, and then learning one set of APIs is done.
All right. I think we call it a day. Yep. Okay. Thanks a lot,
Thank you.
Jonas and Scott. Great session. We hope we see you again at some point in the future. This was a lot of fun, and yeah, have a good weekend, everyone. See you next time.
Thank you very much.
Right, thanks.